Greetings everybody, thank you for joining me for this online presentation of Windows Server Containers, an introduction for the .NET developer. My name is Jeremy Cade, I'm a senior software architect with SSW in Brisbane, and you can find me on Twitter at jcade83. I'd love to hear your feedback on this presentation. If you want to use the hashtag Windows Server Containers, that'd help me out and allows me to find your responses fairly quickly. And it also allows me to keep track of anything that you guys are looking forward to in the future. So today's agenda, what are we going to cover? Well, obviously it's a containers talk, so we're going to look at what are containers. Then we'll take a look at Docker. Then we'll take a look at actually packaging up a ASP.NET 5 application. So that's the new bits, the vNext stuff that's coming down the line. And then we'll actually take that application and deploy it to Azure or Windows Server 2016 Technical Preview 3. So first and foremost, what are containers? Well, Microsoft has their take on it. And they like to say that it's an isolated, resource-controlled, and portable operating environment. So basically, they're saying that containers are a nice little way of packaging up an application, deploying it to a system without having that application have any effects on surrounding applications. Not a bad definition or a bad way of explaining it. But for me, I have a slightly different take on these things. So let's actually take a step back and take a look at where the technology came from originally and where it is today. So first and foremost, containers are a Linux technology, or they were a mainstream Linux technology. So the original Linux container, or LXC, was released back in 2008, and it's something that's still under active development. So the last stable release was in April of 2015. Now, being that it's a Linux technology, it's all open source, so you can actually go out and find the source code for LXC on GitHub. I think it's just github/LXC, so it should be fairly easy to find. But I do give you a fair warning. It is all in C, Python 3 or Lua. So you really do need to have a solid understanding of systems level programming if you want to take a look at that source code and have it make any sense. But if you're up to it, I strongly suggest you do take a look. Now, another key thing with containers is that they are a virtualization technology. It's just at a completely different level. So previously, our standard virtualization was more at the hardware level, whereas containers are an OS level virtualization technology. So there are a lot of things that they share in common with virtual machines, and we'll cover that a little bit further down the track, but there are some significant differences. Now, being that it's an OS level thing, Linux containers require specific functionality that was only available in the Linux kernel. So there are very, very specific things that enabled containers to be around in the Linux kernel long before they were ever going to ship into the Windows Server kernel. Now, one of the big things is that Linux containers are really well battle tested. Now, the big companies, Google, Netflix, Amazon, all of those guys that really need web scale use containers at some level, and they contribute source code and whatnot back into it. So if you take a look at the GitHub repository, I'm sure you can find plenty of Googlers committing back into that, along with people from Amazon, Netflix, Microsoft, etc. So I've basically just told you that containers are a Linux thing. Well, that used to be true up until very recently. So back in June of 2015 at DockerCon, Mark Russinovich, who's the CTO of Microsoft Azure Group, jumped up on stage and presented a ASP.NET application with some Node.js components. He then took that application, put it into a Linux container, deployed it to a Linux box, took the same application, put it into Windows Server container, and deployed it to Azure. This was the first time we'd ever seen this, so this was a big news. It was big news to a lot of people. We weren't expecting it anytime soon. But one of the things that came out of that was that there's two flavors of Windows containers. So we have this thing called Windows Server Containers, and then we have Windows HyperV Containers. To my knowledge, both of those are currently live on Azure. I've only used Windows Server Containers for the most part. I haven't really looked at HyperV Containers, but there are some significant differences between the two, which we should take a look at. Now, Windows Server Containers, or Windows Containers as they're labeled here, have the ability to share binaries and libraries within the same host kernel. So this is something that's a little bit scary for a lot of people. Hyper-V containers, on the other hand, are a little bit more isolated and have a lower level of trust, so we don't trust them as much. And they're more similar to like your traditional virtual machine model. They are a lot more lightweight than a traditional VM. but they are similar in some ways. Now, one of the key things, or the key difference between Hyper-V containers and Windows containers, is that if you take a look on the right-hand side there under the Hyper-V containers, each Hyper-V container gets its own image of a kernel. Whereas Windows containers, they all share the host OS kernel. So that's your kernel level virtualization, whereas Hyper-V is more similar to the traditional VM model. So, containers versus virtual machines. Same but different, right? So, as I said, there are a lot of things that are very similar. We're still having some level of virtualization in there. You still get things that are VM-like with containers, but there is a significant difference, and it's really, really big difference that I have to point out. So on the left-hand side, we have our traditional hardware-level virtualization, so our traditional Hyper-V, ESXi, Zen, whatever you want to use. At the base, we have our host. Our host is our physical hardware. Then we have our host OS, which abstracts away our physical hardware and presents virtualized or software-defined hardware to each of the virtual machines that we install on that host. Downside with this approach is that each virtual machine needs a sizable amount of space. So, typical Windows VM is around 80 gigabytes, or at least I don't deploy a VM that's under 80 gigabytes hard disk, or 4 gigabytes of RAM plus at least 2 virtual CPUs, generally speaking. So they're quite sizable, and they do take time, and there's a large management overhead for a lot of VMs. What we tend to find too is people will deploy one VM per application. So that's a significant overhead for one application. On the container side, we have our physical host, and then we have our host VM and OS file. So basically that could be Windows Server in our case. So we'd have a physical host, or it could be a Hyper-V or something similar, and then we have our Windows Server 2016 Technical Preview 3, which allows us to have multiple containers all sharing the resources of that single host. So what we do get is a lot more lightweight virtualized setting. So when we compare the traditional virtual machine, which is around 80 gigabytes per instance, to a container, which could be small, couple of gigabytes per instance, containers are a lot faster, less resource intensive, and we can spin them up a lot more quickly. So the key level, the key difference is that level of abstraction. So containers are OS abstraction, whereas the traditional virtualization model is a hardware abstraction. So containers, why do we want to use them? What's the business case? Well, the short answer there is dependency hell. So anybody that's ever worked in the Linux environment can tell you pretty much straightforward that deploying one application to multiple versions of Linux is almost impossible. It was very, very hard. We don't really have that same issue so much with Windows, but it is still difficult when you have a mixed environment. So if you're moving from Windows 2008 in staging to 2012 R2 in production, or any number of different versions or different patch levels of Windows, it can be quite painful. Now, the whole idea of containers is that you get to package up all your dependencies in the same container. So it doesn't matter where you're shipping them to. The dependencies are there in the container ready for you. So the claim that the container guys like to make, at least the mainstream proponents of containers, is that this whole idea of write once, containerize, and then run it anywhere. My experience is that this is not true. As with all of these types of claims, you need to take them with a grain of salt. So it is one of these things where I can take an application and containerize it and have it run on multiple different types of Linux instances. That's cool, that'll work. I can take the same application and containerize it for Windows Server, and it will run on Windows Server instances, but I cannot take a Windows Server container and run it on Linux. It just will not work. It does not work that way. Now, one of the other things that you could probably try and upsell to the people that make the decisions as to why you'd want to use this set of technologies is it gets you closer to having that holy grail of all of your environments looking the same and behaving the same. So the idea is that you have your containerized development environment. So we're building an application with a set of dependencies. We put it in a container. We ship that off to staging or UAT. That same container gets promoted into production. Guess what? The same lot of dependencies all the way through. So what are our deployment options? Where am I going to send these containers to? Well, you've got a lot of options today. Now, in the cloud, we have Azure Container Service, which was a recently announced service in the last couple of weeks. As it stands today, it only supports Linux containers, but Microsoft has announced that they will be supporting Windows Server containers as the product matures. We have Amazon EC2 Elastic Container Service. Again, only supports Linux containers or Docker containers at this point. Google Compute Engine is the same, only supports Linux containers. And then, of course, we have the traditional VM plus a Docker engine, which is available on all the major providers. Now, one of the key things that's actually really cool is we have this easy deployment straight out of Visual Studio. So we can take a ASP.NET 5 application, right-click, publish, one-click deploy to Azure in a container. And that's really, really powerful. It simplifies deployment for a lot of people. So if you're in a small development shop that's not interested in having continuous deployment or any of the more mature DevOps practices, guess what? You just got this for free. It's part of Visual Studio, and it's just a simple install to get it there. Now, on premise, we have, again, the normal virtual machine Linux environment where you can set up all types of virtual machines and whatnot. Or you have the option of running Windows Server 2016 Technical Preview 3. But again, I caution this because it is a beta product. So we have the why and the where. So when would we want to move towards a container approach? Well, there's a traditional school of thought. And that traditional school of thought is, you don't really move towards containers until DevOps is a mature thing in your organization. And what I mean by that is it needs to be more than a buzzword. You don't want to have somebody from business coming in and go today, hey, guess what, guys, you're all DevOps now. I have seen it happen. For me, it's hilarious when it happens because it just turns into a giant mess. And you really do need to have that DevOps culture in order to have a lot of these things in place. So the whole idea of having this nice container system is to be able to deploy super fast. So if you're really serious about having fast automated deployments or moving towards having things like infrastructure as code or software-defined architectures, software-defined infrastructure, then that's when you start looking towards a container approach. The other time you'd be looking at a container approach is if you've taken the red pill and you've gone down the microservice rabbit hole. There is plenty of literature available at the moment around reasons as to why you wouldn't want to go to microservices. It's generally the type of thing that you only do when you absolutely, positively need to. But by the time you're starting to make those architectural decisions, you're probably getting close to web scale anyway. So it really is one of these things where if you're at the big end of town, it's a must do because it helps you speed up your deployments. For the smaller development shops, which is the majority of the people that we would be dealing with in Visual Studio, containers become a viable option when you want to have a simple deployment story to the cloud. And what I mean by a simple deployment story to the cloud is a very simple deployment story to Azure or even in some cases AWS. Now, what you do get from Azure is that one-click deploy. The other reason you might want to seriously consider containers is having a nice deployment story from Team Foundation Server or Visual Studio Online. Sorry. So VSO and TFS now have this brand new build system which has built-in ability to containerize applications and deploy them to Azure. So a lot of these things you do get for free if you have these set of technologies already. So we know when we'd be looking at this stuff seriously, but what are the caveats? Well, if you move towards containers, you need to make sure you have a very solid application performance monitoring solution. Now, one of the things that we get for free as a Microsoft shop or anybody that has the Azure platform is application insights, and it's probably it's not a bad solution. It's not the best, but it is a workable solution for the most part. Now, another solution that you could look at seriously would be New Relic or something similar. But again, those types of solutions are very, very expensive, whereas Application Insights has a great price tag of free for the most part. Now, the other thing you really want to consider, and generally this is going to be a web scale problem, is the orchestration side of things. And that's something there where Docker Swarm or Mesos or any of these types of things can actually help you out. But it is a consideration that you need to take into account. So this brings us to the management story. Well, guess what? The management story in Windows Server, or at least for Windows Server containers today, is fairly well fragmented. So with the current Windows 2016 Technical Preview 3, there are two ways of managing them, and they're both completely disparate, and you cannot use the two together. There's the PowerShell way, and there's the Docker way. Now, my suggestion is to use the Docker way. Why is that? Well, Docker has a consistent API. So if you're anything like me and you have to move across a lot of different systems, then Docker is the way to go. If you have really strong PowerShell skills, stick with PowerShell, but I strongly suggest using Docker because it is supported by all the major players. And when I say major players, again, we're talking the major cloud providers, so the Googles, the Amazons, the Microsofts of the world. And you get to use the same CLI, the same skill set across all of the different operating systems that you work on. So in my case, I tend to be on a Mac at home, and I use Docker quite frequently at home for my ASP.NET vNext applications where I'm playing with things on a Mac, working with Core CLR. And then when I'm in the office, I use a Windows machine. So I get to use the same tool sets on Windows and OS X at home without any issues. So it really interacts the same way. So why don't we just jump right in and get some PowerShell cranking and actually start taking a look at Docker. Okay, so I've just spun up a Windows Server 2016 Technical Preview 3 virtual machine that's currently living on one of my hypervisors. And you'll see that I've already got a PowerShell administrator window open. So we're just going to clear all this stuff out really quickly and get onto the root directory of the drive. You may recall that I mentioned using Docker instead of PowerShell as the management medium for containers. Well, that's true. We're just using, in this case, the PowerShell command line as the way to interact with Docker, because let's face it, the command line on Windows is terrible. So PowerShell is about the closest thing we're going to get. So the very first thing we're going to do is just type Docker. Now that basically shows you straight away that Docker is available on this machine. Now, one of the things to take note of is just all of the commands that are available. So for today, the main things we care about are build, info, kill, PS, so that's basically process. It just lists all the containers that are running. Remove image. So remove does containers, remove image does images, and we'll talk about the difference between those in a second. And I think that's about it. So the very first thing we're going to do is just type in Docker and info. So what this tells us is basically, the system time's out. All right, cool. What this tells us is that Docker is actually present on the machine and is running as expected. So it actually gives us a full breakdown of what Docker knows about the system. So we know that there are a couple of images on here already. There's one container running at the moment. And if we type in Docker PS, we can actually see where that container is. Well, it's not running, so let's type all. So there's a Microsoft Python image that I was running earlier. So I might actually just kill that one off. So here's the command for you, Docker kill. Oh wait, no, we don't want to kill, we want to remove. Docker remove because it isn't actually running. So now if I type Docker PS-A, if I type properly, you'll see that there's no more containers, so that's cool. Back to clear Docker info. Alright, so we have no containers, but we do have 7 images. So actually, let's take a look at the images. So the quickest way to do that is type Docker and then images. And you can see that there's actually a couple of images here already. So we have Microsoft Python, Microsoft DNX CLR, Windows Server Core, and a different version of Windows Server Core. So the key one here is actually this Windows Server Core. Now this is the base image that you need for Windows Server containers. Now when we're talking about images and containers, images are basically a virtualized container base. So the easiest way to explain it is that each container inherits from some type of image. So when I deploy or when I want to create a ASP.NET 5 image or container, I need it to inherit from Windows Server Core image. And I'll show you how to do that. And it's basically a thing called a Docker file that allows you to specify where everything's coming from. But in the meantime, let's actually show you how Docker works and how to use Docker to manage images and containers. So the very first thing we're going to do is actually just use one of these images. So let's actually take a crack at using Microsoft Python. Now, the reason we're going to use Microsoft Python is just I know the language, so it's a little bit easier for me. So the very first thing we're going to do is say Docker, and then we're going to say run. So we want to run an image or a container. And then I'm going to say -it, and that means run it in interactive mode. And then we tell it what we're going to run. So we're going to run Microsoft Python, and I want to run it as a command line, so basically the command shell. So if I hit enter, and if everything goes according to plan, we should get a shell very quickly. So let me just open another PowerShell instance so we don't get confused. Drop that one there. So this is actually, if we're now actually running in a container. So if we go back to the command line and hit dir, you can see here that there's Python 3.4 directory. And if I go back over here and type dir, you can see that there's absolutely nothing there that says Python. So this is actually the containers file system versus Windows Server file system. So just to make sure that this is actually what it says it is, and it is a Python installation, we'll go into the Python directory and type python.exe. And here we go. This is the Python REPL. So I can actually do math and stuff in here. Do bit shifts. Well, not bit shifts, just some modulo then. There we go. So we can actually do all types of things that you would normally do with the Python language. So we know that works. So the way to get out of this then is just type exit. And we are now back in the normal Windows Server command line, or the normal Windows Server PowerShell. So let me just fix the colors very quickly. Two of those. Console. What is it? Reset color. No, that's not it. 1 second. It's got having in the wrong place. System.console. There we go. And then if I type clear, cool. So that's basically how you spin up and run a container. So now if I say docker ps, there's no containers running at the moment. But if I say docker ps-a, that'll show me that all the containers that are on this machine. So because we didn't actually give this container a name when we created it, it called it SICPARI. So what we can do now though is we could actually go back in and we can use docker attach. Let's just get the help on that very quickly. Attach to running container, cool. So we're just going to say docker attach, and then we're going to give it the name and hit enter. Oh, we need to start it. So docker start that. So right now the Docker is actually starting that container back up. So now if we go docker ps, we can see that this container is actually running, and we can actually connect to it again. So let's attach to that container. Now we can do all of this with PowerShell. It's just a lot harder. The PowerShell commandlets are, typical PowerShell commandlets. They're very convoluted and they require some pretty funky stuff to make them all happen. So while we wait for that to actually do its thing, there we go. So we type dir. Oh, so we're in system 32 at the moment. We don't want to be there. Let's go back dir. So you can see again we're back in the Python container. So again, if we type Python and actually run the REPL, we can see that we're back to being able to do math and things again. So this system, or at least that container, is completely isolated from, or not completely, but it is isolated from the file system on Windows Server. So if we actually go into program data and then go into Docker, oops, and we'll just open up a Windows Explorer so we can see what's going on. We can actually go into here, and there are a set of different graphs and other bits and pieces, so we can actually dig into these files and work out what is actually what in here. So we can actually dig into these as well. So you can see there, that's one container. Nothing in that one. There's another container. So each of these things actually corresponds to a different container. So here's a DNX container. Actually just trying to find the Python one at the moment. That's a DNX container as well. There we go. So this container here, this is actually the file system for the Python container. So you can see there's Python 34, and there's the DLLs and the exes for Python. Now these are, when they're executed, separate to all of these other containers here. So let's do a quick cleanup. So what we're actually going to do is this still running? No, it exited. So let's just put it back up to a screen that we can read. So you can see here, this is the actual container that we were just looking at, the Superpowers. Currently it's not running, so it's safe to be removed. So we're going to type docker remove that. And then if we say docker info, you'll see that there are no images, or no containers, sorry. But if we look at the images again, we've still got the 4 images that are there. So this number here basically includes all the different versions of these things that are under the covers. So Python may have different dependencies, or the DNX CLR may have dependencies on other versions of this particular image. So they are all accounted for. So that's a fairly quick overview of Docker. So essentially what it allows you to do is quickly manage and maintain different images and containers on a machine. One of the other things actually that I can show you that's very cool is the ability to go out and get different images. So say I wanted to run an Ubuntu image on Windows Server for whatever reason. I can type docker search Ubuntu. This will go out to Docker's Docker Hub. Oh, nothing in there. Okay. Well, you can see it's actually come back with a stack of Microsoft ones. So how about we say docker search go. Oh. I don't know why it's only giving us Microsoft packages, but on a normal Docker installation, you will get a whole range of different packages. But again, this is technical preview 3, so these things are fairly new. And we do have a couple of options here. So we have Microsoft IIS, DNX, CLR, Ruby, Ruby on Rails, Python, Golang, MongoDB, Redis, SQLite. So all the standard things that you would actually need if you were serious about building a modern web application. Cool. All right, so let's actually jump across to Visual Studio and take a look at how we actually containerize applications and start looking at actually getting something deployed. Okay, so I've just spun up a new instance of Visual Studio 2015. A couple of things to note. I'm on the latest version of 2015, so it's 14.23.107, development 14 release. One of the other things to take notice of is I have the Visual Studio 2015 tools for Docker Preview 0.7 installed. Now you can get those by going to Tools, Extensions and Updates, and just doing a search from the online stuff. So if you type in Docker, you should find it fairly easily. Now, the other thing that I have here is just a file new project, ASP.NET 5 starter application. It's just all the stock standard stuff. I've just called it container demo just so we have a working ASP.NET 5 application. If I was to hit F5, it'd spin up and you'd see all of the standard ASP.NET 5 stuff. Now, what I have done, just to save a little bit of time, is I've already started a publish to Azure Docker. Now, these take quite a long time, so you can see it had to push up 180 megabytes. So this has been running for, I think, probably 15 minutes. It is quite slow, so it is one of those things that we kind of want to do and save your time. But I'll walk you through the steps to get all that stuff set up. So the first thing, after you create a deployment profile to Azure for the Docker stuff, is it will create a Docker file for you. Now, what it does in the Docker file isn't quite what you need for Windows Server. So the very first thing you'll need to change is this from line. So originally it has from Microsoft ASP.NET DNX Beta 8, whatever the current version of the DNX stuff is. What we want though is the Windows Server core things. The next step is to change the working directory. So actually I'll walk you through this part thing. So each of these is a specific command. So from basically tells it which Docker image to inherit from. Add tells the Docker file or the Docker container which files to include in the container. So this is basically saying take everything from the current root directory and add it all into app. So we're going to map our current root to the app directory. Now we want to tell it that the working directory, so anything that's after this file, uses this directory as its root. So we're going to say anything from app root, and then the very next command that'll run is this web.command. So to get all this information, we have to kind of look at the publish profile. So when Visual Studio or DNX or any of the VNX stuff does a publish, it has a certain file layout. So we have approot logs ww root. So ww root is all the static files, so CSS images, JavaScript libraries, etc. All of the CS and HTML views all live in approot source and then the name of the application. So we can see in here, these are all of our CS HTML views, or all the Razor stuff. But in the root directory of the approot are all of our commands that we specify in the package, or sorry, in the project.json. So the one that we care about is web commands. That basically tells the application to run the Kestrel server. So that's what our Docker file looks like. So when our publish happens to Docker, it actually sends all the information and then goes through each of those steps. So it says, give me the Windows Server core, gets that, and now it's adding all of those files into that specific directory, and then it'll go through and run the rest of those steps. So as I said, that does take a while, and that's accessible from right-click publish, but we'll come back to that in a second. Now, the other thing that I've done ahead of time is I've actually done a file system publish so that I could see what that file, what that directory actually looks like. So this stuff here is the stuff that I'm actually going to copy and deploy to my Windows Server 2016 local hypervisor instance. Now, ideally, we wouldn't be doing it this way. We wouldn't have some type of continuous deployment or automated deployment. But in this case, I just want to demonstrate to you how to actually go through and build the Docker containers. So if we jump across to my Windows Server 2016 installation again, you can see here that I have that same file layout, same files, all the rest of it. Now, this is at the moment just sitting in C drive, apps, and then the container demo stuff. So in there I have a Docker file. If we look at this Docker file, it'll look very similar to the one that is on my other machine. So from Windows Server Core, add app. So the difference here is I'm going to a subdirectory rather than the root, but everything else is the same. So what I can actually do with this now is if I grab a PowerShell instance, we can actually go and build a Docker image. So let's just take a quick look and make sure we've got the right images on the machine. So there we go, Windows Server Core is there. Let's take a quick look and make sure that we don't have any other containers that we don't want floating around. So there's no containers on the machine at the moment. And if we type Docker info, we'll get a good indication that this is the case. So there's no containers, but we have the 7 images that we had before. So that's cool. So let's make our way down into the directory we want to look at. So it's in container demo, and there's our Docker file. Now, the command we're going to use is docker build. So docker build takes a set of options, a path, that's basically going to be the name of what we want, and optional URLs and all this type of stuff. So what we're actually going to do is use a flag that's /t. So /t is the tag, so it basically gives it a name. So it's an optional name for the image. So we're going to say docker build and then /t, and we're going to call this container demo image. And then the path to the Docker file, this is what this actually is. It's the path to the Docker file. In this case, it's just the local directory, so it's just dot. So this is actually going to go and build our Docker container for us. So it's a very simple command line. It's just docker build -t to give it a name, and then dot. And that's only because I'm in the right directory to start with. So it shouldn't be too hard, it should be fairly simple. So you can see it's flying through all the information. So again, we saw this in Visual Studio. This is the exact same step the Visual Studio had to do. So you see it had to send all of that information to the Docker context, to the Docker daemon. You can see it's still actually working through its steps there. But on my local host, it's a lot faster. You can obviously see that. So we're up to around 130 megs. It's got to go to around 180. So if we just wait patiently. Oh, there goes a bit more this time around, 190 odd. So I may have some additional files in this one that I shouldn't have. Maybe 203. So maybe it's just a little bit different because those files have been extracted on the hard disk here. So now what it's doing is it's basically going through and adding all of the files that I told it to. So everything that's in app now gets added to /app. So it's basically a mapping. So essentially what this is doing is copying the files to another location on disk. so that when when I create a container from this image, it'll actually know which files to bring across. So again, this shouldn't take too long. Now essentially what we're going to do after this is another step that we're going to take. So let's get a new PowerShell window. And if we type docker, let's just move this one over here and get the other one up so we can see what's going on. So you can see that the machine is starting to slow down because we're doing a bit of work. So if I actually get the, wrong one. That's the one I wanted. So if we actually get the task manager as well, we can see that the machine is probably doing a bit of work at this point in time. Let's go to performance. So you can see the CPU is at 97%. So it is actually trying to work fairly hard. So we'll just go into here and we'll just say Docker images. And you can see at the moment there's still only the 4 images, but by the time this finishes there'll be an additional image there for us. So essentially once this image is completed, the next step is to actually create and run a container. So in that case the command is docker run. What run does, run creates a container and then runs it at the same time. So the usage is docker run any options that we want to push in, the image, and then the command that's going to be run after that image is executed. So you saw me do that before with docker run Microsoft Python. We ran the command line interface so we could actually get in there and look at the file system. In this case, we don't need to really pass in a command as such. So what we're going to do is docker run, and let's have a look at the command line options for it while we wait patiently. You can see there's quite a lot in this case, so I'll make it full screen so you can read them. So what we're actually going to do is we're going to pass through name, so we can assign a name to the container. And then the other thing we're going to pass through is the ports. So in this case, we're going to pass through ports 80 and 80. So when Kestrel runs, it should execute any requests on port 80. So this may or may not work today. I've had some issues with this type of thing in the past, just on my local machine thanks to hypervisor and my VLAN setup. And as you can see, we're finally getting into the working directory, so now we're actually running a set of commands. So if we get the other PowerShell window, come back over here. Just wait for this patiently. Alright, so let's just full screen this, clear that, go back to the root directory, clear it again just so we can see what's going on. And if we say docker images, so we now have a new container image. So there's our container demo image. So what we can actually do here now is actually create an actual container from that image. So we're going to say run, give it a name, and this is going to be our container demo, and it comes from container image, and we want port 8242 port, I believe it'll be 5000, but we'll double check this in a moment. So we'll just call it container demo 5000. So the other flag that we'll probably want to pass into this would be, I think it's -d. So let's just take a quick look. Docker run help. I believe -d, there you go, is detached. So run container in the background and print the container ID. So if we pass in -d, we're not going to see anything. But if we pass in just this, when that container runs, we should see hopefully something popping up saying that Kestrel is listening on a particular port. So let's just wait and see what happens here. Cannot start container. Okay. So maybe I've messed something up. Let's take a quick look again. Docker PSA. So what we're actually going to do is remove this container. I think I've actually got the commands in the wrong place. So we'll say docker remove and that container, and then we'll recreate it. So it may be that I have all of these things in place. So that's a parameter, so it should be in the parameters section where it expects it, rather than where it's expecting an image name. So again, if we look at the usage, we can see that it should have been docker run options image command. So I passed through an additional set of options where command should have been. So that was my fault. So right about now we should be spinning up a new container. So if we say docker ps, we should see that. There we go. So it's running command, web command. And we should see some output. There we go. So it should be listening, hopefully, if this is all working correctly on localhost. Though, as I said, I've had some issues in the past with this particular machine. So if I go to localhost, we should see something that looks like ASP.NET. Otherwise, it'll drop out to Bing. There we go. So essentially, I have some issues with this machine and the VLAN setup that I actually have on here. But the idea is to have port 80 forward to port 5000. The other thing you'll notice here is, see, the ports are blank. So there is something going wrong here. Now, if we were to do this, if I go back to my other machine, oops, not the one I wanted. So if we go back to PowerShell on my other machine and we type ps-a on here, so again, this is looking for machines running on Azure. Once this actually finishes up, it'll actually show that there'll be a correct port. It'll say port 8080 running against this. So what I've actually done now is I've told the application to kill itself. So if I say docker ps-a, you can see that the application is exited. So the next step from here would be to remove. I no longer wish to use this container, so we'll remove it. Boom. And then let's go into Docker images, and you can see here as well there's a container Docker image demo, or container demo image. Say I no longer wish to have this particular image, then I would also run the container or the image remove command, which is docker remove I for image and then that name. You can see it's deleted all the files associated with that. So if I go back to Docker images, you can see that's no longer there. And if I run docker process list, there's nothing in the containers. And just to make sure that there's nothing in there at all, nada. So ideally what would happen when we create these new containers is that we'd be able to access them from another location. But as I said, I have some issues with this particular setup at the moment. It's something to do with HyperV. And is something that I've been investigating for a while as to why this isn't particularly working on this machine. Okay, so as you've seen, some of this technology is still a little bit flaky. So that brings us to kind of our last question. Where do we stand today? Well, containers, at least on the Windows stack, do show a lot of promise for automated deployments. Now, they are a lot more mature on the Linux platform, but it is something that will be worked out over time. So it's really important to keep in mind that Windows Server containers are still in technical preview. Now, one of the really nice things is that Docker workflow works across multiple operating systems. As I mentioned, I use that workflow at home on OS X machines, and I get to now use it on Windows machines. The other thing that we do need to take a good hard look at is the amount of bugs that still need to be worked out. One of the other things that is very, very useful for your average .NET developer is that Visual Studio integration. So over time, that's something that's going to improve, and that whole Azure deployment story is going to be very, very nice over time. But it does take time, and it does need time for that tool set to improve a lot. So that probably brings us to the end of today's presentation, or at least the wrap up. So I'd like to thank you all for sticking around and listening. Hope you can send me a whole stack of feedback. I'd love to know what you think about this topic. As I said, hit me up on Twitter, jcade83. And if you're interested in any more great content or would like to get SSW to help you out with your enterprise development, visit www.ssw.com.au or send us an email. We're always looking for great partners and fun people to work with. So once again, thank you very much.